electrical theory for both the electrician and the HVAC technician. Taught very differently, okay? Even though the concepts, the principle of electricity, you know, you have your voltage, your amps, your ohms, resistance, that doesn't change. But here's, you know, and yes, there is a huge difference in the two trades, okay? One bends conduit, one goes by the NAC, one cares about wire sizing because it's really important. You know, the HVAC tech, you come with with units that are pre-wire sized. You don't necessarily worry about 12 gauge wire, 10 gauge wire, 8 gauge wire. Okay, but let's see where they can help each other. Well, let's start with the electricians. Electricians can teach HVAC technicians, hey, at your transformer, you have primary winding, secondary winding. Okay, you have a primary, okay, you have a delta configuration or Y configuration, and then your secondary, you have delta or Y. Okay, at your secondary winding, you have two legs of 120 and a center tap neutral, which is tied to ground. At your transformer, you have ground rods. Okay, those two legs of 120 with your neutral work their way to your main panel. Same thing, main panel, neutral is tied to ground. You will have ground rods. Okay, now let's look at a 2-pole breaker, two legs of 120. Okay, that is enough with a capacitor to spin a motor. Without a capacitor, okay, two legs of 120, let's say you have a popped capacitor, two legs of 120 will not be able to spin the motor. Okay, you will hear a humming noise and the motor will get hot, but it won't spin. So electricians are taught the engineering of electricity theory. HVAC technicians are taught more in a practical way. So you're taught, look, this is a capacitor. This is in microfarads, because farads, very big capacitor. Microfarad, tiny. Okay, microfarads, you have a dual capacitor or a single capacitor. You know, you have your common, you have your fan, you have your Herm. Your fan and Herm go to your start windings. Your capacitor essentially turns single phase into shitty 3-phase, oversimplified. Okay, electricians do not see it like that. You see it as, well, in an inductive load, voltage leads current by 90 degrees.